All right. We talked about the heating curve, and we said that there are different sections on the heating curve, and because there are different segments on the heating curve, we have to use different equations. We need to know what these equations mean. So we're going to start with Q is equal to MC delta T. What this means is I have the heat, which is Q. If you remember when we were doing definitions, we said that heat is always calculated. It is never measured. There's no piece of equipment in this room that measures heat. Okay? The unit that Q will be in for this class will be joules. You might see kilojoules at times, but the vast majority of the time you're going to be in joules. Bless you. What do you guys think M is? Motion. Not motion. Mass. It is mass. Why is there just a J right there? What is the unit for mass? Grams. We use grams. All right. Now I'm going to go really important here because what's the J? Joules. It's a unit of energy. Joules. All right. This one's going to be a new one on you guys. This is brand spanking new. We've never talked about this before. It's not Celsius. It's not even change. This is a constant. Each element or each substance has its own constant. This constant is known as the specific heat. Because it's also known as the specific heat capacity, so they use the C for capacity. So whenever you guys see specific heat or specific heat capacity, it's the same thing. And it means the amount. Excuse me, guys. We are recording, and I'm hearing you up here. So I know that this is being recorded, that what you're saying back there. We can stop talking about all the other stuff because I'm recording right now. Yes. Because people need this. So stop talking, please. It is the amount of energy required to raise the temperature of 1 gram of a substance by 1 degree Celsius. So what we're saying is every substance has a certain amount of energy that it takes to raise its temperature. Okay? This amount is how much for each gram of that substance. No matter what the sample size is, 1 gram will take this much energy. Okay? So it's kind of important that we note something here. Aluminum has a specific heat of 0.900 joules per grams degrees Celsius. So that means for every gram of aluminum, it'll take 0.9 joules to raise its temperature by 1 degree Celsius. Okay? So that's going to take a lot. It doesn't take that much energy, does it? How about a comparison? H2O is 4.18 joules per grams degrees Celsius. So that's 4.5 times more. Water is 4.5 times more energy than aluminum. So what does that tell me about those two substances? Because that's what it is. If I put both of these samples, I put a sample the same mass. If I put the same mass of water and aluminum on the same heat source for the same amount of time, which one will heat up faster? It's the aluminum. Why is it the aluminum? It takes less, so it won't. It'll heat up faster, and it will also reach a higher temperature. How do I get what? I'm telling you what they are. We can calculate for some substances, and that is something you guys will be doing. You will be calculating what the specific heat is. If I give you every other part of the equation, you're isolating and solving for C. You can do that. If I give you every other part of the equation, you can isolate and solve for M. You can actually solve for each individual component. Each individual component. In fact, we're going to go so deep that when we get to the next part, we're going to break it down even more than just the delta T. Yes, Bree. The next quiz will be next Thursday. They decided to add one more. Well, it's not up to me. Hey, I didn't know that they were going to add it on. Good. Last one is delta T. What does delta T mean? It is the change in temperature. There is a specific way that we find the change in temperature. The delta T is equal to the T final minus the T initial. Yes, Chris. Why is the triangle mean delta? Because that is the Greek letter for a capital D. Oh, okay. Which is delta. All right. So we have Q, we have M, we have C, we have the delta T. And delta T breaks down into T final minus T initial. So we can actually break it down and find what was the initial temperature or what was the final temperature. As long as that's the only thing missing, I can do that. Okay? But there's another equation we had too, wasn't there? So if Q equals MH, we know what Q is, right? We already knew what Q was. We already knew what M was. What is the H? H, its actual name as you move forward is you will hear it called enthalpy. Please stop. Enthalpy is the amount of energy required to cause a phase change. Okay? So there are different phase changes that we have. If you remember, we said that we call the phase change melting, we call that fusion. An example of the reason why I didn't put any values in here is because we used to give the delta H of fusion as 6.01 kilojoules per mole. We don't do that anymore. Now we give you the delta H of fusion as 333 joules per gram. So in this class, anytime we're doing the phase change, the units we will be giving you the delta H in will be in joules per gram. So that means you won't have to do any metric conversions and you won't have to do any mole conversions. When we taught this to juniors, they had to do metric conversions and mole conversions to do their thermochemistry. What? When I first started, we taught juniors. Then they started allowing sophomores to take it. And then 5 or 6 years ago, they changed it to freshmen only. I don't know. That's not for me to decide.